Bonsoir. Bonsoir et bienvenue à Google Montréal. I'm going to talk in English since the presentation is going to be in English. How many of you is your first visit to the office? Excellent. So welcome. My name is Shibal Murad. I'm the R&D director in the office. And I'll give you a brief overview of the office. We have a small office by Google standards. We have around 50 developers and software developers and business developers in the office. We work on Chrome and web security. And we are constantly growing the office. So we are looking for software developers who, in many areas, machine learning, Windows development, front-end development, server development. So we have James, who I don't see, but he's a recruiter. If you see anybody with a t-shirt like this, you can ask them questions about joining Google. There's one guy here. I'm happy to have Alex here. And this is the end of a 3-day visit to Alex to the office. So Alex has been giving us training about Windows development in the office. He has a long background in long expertise in Windows. He has written a book called Windows Internals, which is the Bible. And he's going to talk to us about ReactOS, which is an open source Windows platform. That's pretty amazing. Just to give you like an idea of how good Alex is, and I don't say this for everybody, but this is the case. So he has been training our software development team, and the team in Montreal is actually one of the Windows expertise teams at Google, and in Chrome in particular. And when they asked me would like to get Alex as a trainer, I said, well, come on, you guys must know everything. Why do you need Alex? So after the first day, I asked people how it was, and many people said, oh, I have a headache. So this guy is good. So I'll leave it to you, Alex.
Thanks. See if this works. Hello. I'll stick with this. Take this off. All right. So thanks for coming. So a little bio by myself. Shibal said a lot, but I'm actually a local Montrealer. So I studied at Concordia, just a few blocks away from here. Ooh, Concordia? No. Yeah, that's what I thought. I started working on ReactOS in 2004. I was still in high school, I think, and basically discovered this project for these people who were trying to re-implement Windows NT. And I had a really big interest in operating systems, and I looked at Linux, which was open source, but had a very tough learning curve. It's hard to get in the Linux kernel, I think, when you're 17 or 18. Looked at Mac OS, which was open source, but you can't really submit your patches to Apple, and ReactOS, which is Windows, but not really Windows. So I thought, this is interesting. So I got involved with that and pretty much spent 5-6 years working on it while studying less and less and coding more and more on ReactOS. And then eventually left Montreal to go work at Apple. I've actually been an intern there for a few summers. Logically, right, you work on a Windows clone and then you go work at Apple. Apparently Microsoft didn't think I was good enough. So I worked at Apple on the iOS kernel and on the iOS platform, and then went off to a startup in the Bay Area. Ironically, while working at Apple, I was approached by people from Microsoft to write a book on Windows, which is called Windows Internals. So I was working at Apple writing a book on Windows, and then Microsoft asked me to do training and go to their campus and teach their Windows developers how Windows works, while spending my nights reverse engineering how it works to undermine their operating system to make a free open source version of it while working at Apple. So I got really confused, and I kind of left ReactOS for a few years, and only recently came back to it and realized, okay, now I know where things are. I'm no longer at Apple. I'm doing less training at Microsoft because Google pays better, and I can do other things. So what is ReactOS? ReactOS is an open source reimplementation of Windows, and not Windows 95, but Windows NT, which is how we call the family of Windows operating systems with NT4, Windows 2000, XP, Vista, 7, 8, 8.1. So none of the DOS-style Windowses. ReactOS tries to re-implement Windows NT 5.2, which is Server 2003, or XP 64-bit, but not 32-bit. And I'll explain why that's an actually important difference. The kernel is 100% written from scratch. So it's not based on Unix. It's not taking Windows applications and emulating them. It's actually running a Windows kernel that we wrote and running Windows DLLs and Windows applications. So it has the Windows bootloader, the Windows kernel, the Windows DLLs, the Windows drivers, or re-implementation of those things. And the hope is you can take any Windows binary or take any Windows hardware that you have and just run it in ReactOS without having to have a Windows license, and with being able to see what is the OS doing, learning, not having a binary file, but actually having C code that you can look at, how does Windows create files? Well, I can go look at ReactOS and see how that works. So everything from the boot sector down to the data files that contain language strings are all trying to re-implement this Windows behavior. Now, a lot of people would ask, why are you wasting your time re-implementing Windows? Don't you have a life? And yeah, probably not. But for myself and for many other developers, especially when you're just young and starting out, it was a really good way to get exposure to Windows. Windows development is something that you don't normally learn in school. Windows kernel development is definitely something you never learn in school. So the chance to actually play around with this little sandbox, try to implement a Windows API, try to see what happens when I try to schedule threads this way, and being able to boot into something that looks like Windows and works like Windows, that I don't need to learn how Linux works, I don't need to have a Mac, I can just take ReactOS, boot it, and kind of see what happens when I change an API around, or when I do something different. Or let me try actually implementing some functionality. Maybe I wrote a Visual Basic app when I was young, it's not working in ReactOS, let me try to make it work. So it's a learning platform, I think, for a lot of people to give them a chance to work in a Windows environment, whether they want to do kernel mode stuff, whether they want to do user mode, whether they want to do a simple paint application, because ReactOS is not just a kernel, it's everything that Windows has, ReactOS also has to have. There's also other reasons why some people work on ReactOS. One of them is they're actually hoping to really get rid of Microsoft and make sure that everyone in the world will be using ReactOS. I don't think that's ever going to happen, but some people can dream. And there are actually legitimate cases where, for example, we've heard about companies where they sell movie ticket systems. You go to a movie theater at the Paramount, you're trying to buy a ticket, and all they have is a little app that lets you buy a ticket. But they're running Windows because someone wrote it in Visual Basic or Java or whatever, and they're paying Microsoft millions of dollars for thousands of ticket machines around the country to run one app that prints a ticket. Now, a lot of smarter companies would probably have a web app and run Linux on it, but some companies just can't move away from Windows. So hopefully, if they run ReactOS, it installs the same, it looks the same, and it runs the same app, they can save that money. Now, that wasn't my motivation, but it's something that you can do. I know another use of ReactOS is companies that are building Windows products, and their products are hitting bugs in Windows, or they're not working like they expect to. The Chrome developers are trying to get Windows to do something, and Windows doesn't do it right. Well, with Windows, all you have to stare at is a big binary file, and you have to reverse engineer it to find out why is Windows failing. With ReactOS, you can see what is the actual C code, human readable comments, human readable code. They're going to tell you, here's what Windows normally tries to do. So it can be a great helper to people that are actually developing for Windows. And another use, which I've seen, is let's say you're building a Windows driver, and you have all these Windows functions that you're calling. Windows has a lot of nice libraries for compression, for building a binary tree, for scanning through a string and converting it. If you take your driver and you put it on Linux, you don't have the same functions. You may have alternates, and other times you have to re-implement them. But you can actually take part of ReactOS, link it as a static library, add that to your Linux driver, and now you have the same functions when you're running on Linux as well. So it can help with cross-compatibility as well. So why NT 5.2? Why Server 2003? So you can keep in mind this decision was made in 2006. So XP was out at the time, and XP was a really popular OS. It took the really good design that NT and Windows 2000 had that was really solid and scalable, and took the Windows 98, 95 kind of friendliness that users liked. So it kind of had the best of both worlds. You had the good design that wasn't based on DOS, and you had DirectX, you had hardware acceleration, you had games, and XP is still so popular that people still use XP today. It's been a 12-year-old OS, and it's still one of the most commonly used operating systems. But XP wasn't perfect. And so before Vista came out, Microsoft worked on an update of XP for server systems that they called Server 2003. And this is an actually fairly different kernel, fairly different semantics. They improved it a lot, but they only ever released it for servers. Now, the 64-bit version of XP, which came out a few years after XP, had this too, but no one really ran XP on 64-bit. So very few people actually know about Server 2003, that it was this really good OS that was XP, even better, before Vista, because then people remember Vista, and well, we all know what happened there. Windows 7 cleaned up a lot of that, and today if I would start ReactOS, I would probably aim for Windows 7, but this decision was done in 2006, and we picked Server 2003. Mind you, there are very little applications today that won't run on XP. Pretty much everything runs on XP. Even more stuff runs on 2003. Very few apps require Vista or later. So it's not really hurting us that we're targeting this fairly old and legacy operating system. Surprisingly enough, ReactOS is actually an almost 20-year-old operating system. These guys got around in 1996 and decided to start FreeWin95, a free version of Windows 95. After a year, they gave up and they started ReactOS, which is a free version of NT4. And then they had two developers that wrote about 100 lines of code every week. And Microsoft was releasing new versions of Windows faster than they could keep up, and then they could keep up. There was only two of them, and so nothing really happened. 2004 is when ReactOS first had a GUI. And that's when I discovered it. That's when I saw on a /dot, hey, here's a Windows clone, and there's actually a GUI. There's something behind it. Before that, it was just kind of text. So I joined, and from 2004 to today, ReactOS went from 20,000 commits to 60,000 commits. And you'll see some code metrics where project really took off because people started seeing a GUI, people started seeing a future behind us, and a lot more developers joined. But a lot of people call it a 20-year-old project because that old legacy, free Win95 story. This is how ReactOS 0.2 looked like. This is what made me want to say, I want to dump all my time in this. This looks cool. And you'll see in a demo, it looks a lot better than today, but it was impressive that this team of 4 or 5 developers actually got this far to actually have. And these were actually Windows applications that were being run. Rendered horribly, but they were running. So ReactOS is very, very big. It's 6.25 million lines of code today and 60,000 SVN revisions. In fact, other than Haiku, which is an open source version of BOS, which you've probably never heard of BOS, it's an older but really cool operating system, ReactOS is the only open source OS project. If you look at Linux, Linux is a kernel project. Linux doesn't work on all the libraries and all the apps that ship with Linux. It has lots of libraries, applications, shared libraries, drivers that other people work on. But the Linux project is mainly the stuff in the kernel. Now, Fedora and Ubuntu, they're mainly taking everyone else's code and packaging a release with it, which is hard. It's hard work, and they have to do it. But there aren't many projects out there that are re-implementing an entire OS. Every library we write, every little application, ReactOS Notepad, ReactOS Calculator, ReactOS Paint, we write the kernel, the drivers, everything has to be written from scratch. And so this actually puts an incredible strain on the tools that are out there. You tell a compiler to build an OS, it's going to freak out. In fact, the first time we got Visual Studio to have a solution file for ReactOS, it crashed. I was like, I want to have nothing to do with this 6.25 million lines of code project among 500 binaries. And a lot of other open source projects that help and a lot of tools that build ReactOS, actually, we found bugs in them because of the huge size of this project and the huge depth of it, and we'll go over some of that. It's actually surprisingly popular, depending on what your definition of popular is. Every release gets about 1 million downloads. So we release about every 2-3 months, and 1 million people are actually interested enough in trying a barely working version of a Windows clone that's based on XP. That's kind of cool. We got nominated as Source and won SourceForge Project of the Month a few times. We participated in Google Summer of Code for 2 times, and we keep being invited at various conferences to speak about what we're trying to do, which is surprising because the Linux community and the open source community doesn't really like Windows. They would rather see Windows die. And so the fact that they actually care about a re-implementation of Windows is somewhat surprising. We have a community of about 200 people on RC that are hanging out there, 50,000 people on the website. We have forums, we have a mailing list, so people are always kind of keeping in touch. In fact, there's actually a school out there that studies OS design based on a book some Chinese guy wrote called Windows Kernel Analysis with using ReactOS, and it's 2,000 pages of ReactOS source code and explaining this is how an operating system works. So an entire army of Chinese students are looking at my bugs, thinking that's how an OS is supposed to work. Scary. In Russia, they just launched a course taught at Moscow Technical University. It's an OS course, and it uses ReactOS. It's an example of how an operating system works. Putin received a private demo of ReactOS and has a picture going thumbs up. It's really freaky. We actually have, the reason we have stuff in Russia and China and all over the place is we actually have developers all over the globe. We have about 30 developers that contribute some from time to time. We have about 150 developers that have developed some code at some point. It's also funny to see people leave for 4 or 5 years, they come back, they leave. We don't actually have, we don't pay any of our developers. I never got paid, no one else got paid. And so any time we spend on ReactOS is just basically time we donate and things that we like to code on. We've got people in high school, we've got people that are 60, they're senior managers in a company, and from time to time they want to write some Windows code for ReactOS. So there isn't a lot of, there isn't like a seniority level, there isn't a lot of big coordination, it's a lot of ad hoc. And collaborating with 30 people across 12 different time zones is fairly hard. In fact, we actually have on the ReactOS page, that, by the way, is what happens on reactos.org when you put in the wrong URL. It gives you a fake blue screen of death. But we have a people page, and if I click on developer, we have developers in Europe, Asia, and all over the US and Canada. If I add language maintainers and moderators, start having some people in India, and if I add newsletters, authors, and translators, it's going to open up even more people. And if I add users, it's pretty impressive. We pretty much have users all over the world except Antarctica. So no one's paid, and it's really interesting to see basically random people on the internet working together trying to work on this. We do have a monthly status meeting, and that's kind of where we try to set a direction, set a tone, but people really come to ReactOS, and I feel like re-implementing an open source version of Paint. Go ahead, and it'll be ReactOS's Paint, as long as it looks and behaves exactly like Windows's Paint. So, you're re-implementing all of Windows from scratch, behind Microsoft's back. What could go wrong? I am not a lawyer. I know that reverse engineering is supposed to be legal in some countries and is not illegal in many countries. Now, not illegal doesn't mean legal, it just means not illegal, as long as you're not breaking any DRM or cracking. But there are patents, right? Companies can patent algorithms, they can patent the way a function works, and if you're re-implementing it, even if you're doing it from scratch, even if you're doing it with your eyes closed, if it does the same thing the other algorithm does, you can get sued. Now, some countries don't have software patents, and who knows what Microsoft patented. In fact, I don't want to know. Patent law says if you don't know, you're going to pay less. If you know you're violating something, that's worse than if you don't know. So I don't know about any patents. So if you ever want to license, make money off, start a startup on ReactOS, go see a lawyer. I'm doing this for fun. So ReactOS is basically a huge project, and it needs a lot of infrastructure. We actually have 4 servers in Sweden that some university student donated to us on his campus, 2 in Germany, 1 in Poland. So all our services run on that. We run Atlassian tools. So if you've ever worked with Jira, Crucible, Fisheye,
That's what powers our development. We use BuildBot for building, and I'll show you what that does. CVP check, we use Doxygen for documentation, and we have a whole suite of regression testing tools that are custom made to build every version of ReactOS, run tests, and it's quite interesting on how you test a whole operating system if you've ever done testing. And we use Subversion, and we also have a Git mirror and a code.google.com mirror. Online, we use Drupal, iServe, MediaWiki, Nginx, PHPBB, so we have a whole team that knows nothing about OS development, but their job is to keep the website alive, the forums, maintain the servers. So like I'll say at the end, whether you're a PHP developer or a Linux kernel developer, there's probably something for you to do. So just maintaining all these servers and all the website code and all the databases requires a whole team. So I want to show you some of the really cool services we have that are actually making the life of developers and users easy. So other than the people map, so that's our Jira page. So that's where I log in every morning. Well, not every morning, but when I don't have too much work at my real job. See all the bugs that are assigned to me. Something about the memory manager not making any attempts to reduce memory consumption. Who needs that? The more important bug to me is Minecraft does not start up. That is a big bug. People would use ReactOS if we ran Minecraft. So Jira is an open source, well, not open source, but they're a little startup that does these bug. It's basically a replacement for Bugzilla. Let's see. I'm trying to find. So every build goes on isos.reactos.org. So we have a server here that has every single build since 2007 or 2006, which is great for regression testing, because someone can pick up a build from 2007, send us a bug report that said, this used to work in 2007. It doesn't. Fix it. And someone has to find out in the last 6 years which build broke that person's app. It's not a lot of fun. That's our forum. Actually, let me just put the website directly. It'll be easier. Oh, there we go. Testmat. So every time there is a build, a bunch of servers build it, open up a virtual machine, and test it. And in fact, we build it with Visual Studio, and we build it with GCC. That's what I'm going to talk about. And then we test it in a virtual machine, we test it on a real machine, and we test it on a different virtual machine that's made by another vendor. Because it turns out when you make an operating system, just like when you make a web page, different browsers render it in different ways. Well, different virtual machines run code in a slightly different way. Different compilers will actually build code in a different way, and sometimes you can have bugs due to the compiler. And so these are the last few revisions that got built, and then they're all tested with an extensive suite of testing tools that I'll mention. That I can pick 2 of these versions, compare the results, and it's going to show me all the tests we ran, and I'll talk about a test a little bit after. My machine is lagging. Let's make it a new window then. And there I can see how long it took to boot, how many context switches, how many interrupts, and what the test results are. Obviously, red is bad, green is good, and I can look at what actually changed between those 2 builds. And between these 2 builds, Quartz filter mapper now runs 2 less tests. So for whatever reason, it's running less tests than before. That's not usually a good sign. That means the test crashed. And this other thing which crashed and wasn't even able to test is now running 240 tests. So that's good. The other one is not so good. And so hopefully some developers looking at what did they change in his build to make that thing better, but the other thing not as good. So this is how we keep track of, are we making the project better, or are we just making things worse and worse and worse and worse? We also have a get build system. Get build. Oops. Thank you, Google. Where you can just put any revision you want and get a pre-made boot CD and install CD so you can actually try it out. So you don't have to check out the code, you don't have to be a developer, you don't have to compile it by hand. Any build you want, you can run it. And so for people who are doing testing for us, that's great, because if they find a regression, we tell them to test for a revision in the middle, and they can just get the new build, try it out, boot it, as we'll see how to try it out, and fix it. So we have a whole bunch of services that people created on the website that have nothing to do with Windows or with kernel writing, but with really making our job easier. I'll also show you BuildBot. So if I go to build.reactos.org, oops, build. That's our waterfall display, and I'll be able to see all our servers, what version they're currently building, if it managed to build it or not, any warnings that came through from that build, and then I'll be able to see them testing it and what the results of the test were. So if something did fail during a test, I can see the whole log of everything that happened. And this is good to catch developers that are checking in broken code that doesn't even build, or developers that are adding regressions. So up until 2011, React was built with GCC and MinGW. GCC is the open source GNU compiler, and MinGW is the cross-compiling kind of patch and tool set around GCC that lets you build Windows applications with GCC. Now, in terms of actually constructing a build system, instead of using make, we decided to make our own build system called rbuild. Turns out a team of OS developers does not make a good build system. So around 2011, we scrapped rbuild and switched to CMake. And CMake is freaking awesome. Because CMake not only allowed us to build with GCC, but it also allowed us to build with Visual Studio. And we first had Visual Studio builds and Clang builds, which is kind of Apple's compiler these days. And Visual Studio has a static code analyzer, and Clang has an analyzer too. So we basically get more code coverage, see what bugs we have, and the more compilers you build your code with, the more you're going to find errors. That's the truth. And we use a project called Ninja, which is even more freaking awesome, which basically makes our CMake build 10 times faster. Ninja is really, really cool. So once we had Visual Studio, the really nice thing we had was we now had PDBs, which are Microsoft symbol files that let you debug stuff that you're building with Microsoft tools. When you're building with GCC, you have the open source tools, but they're not really meant for debugging on Windows, especially not an operating system. And so we had our own custom debugger, we had GDB support, but it didn't really work that well. With Visual Studio builds, we could actually use WinBag, which is the Windows debugger. And you can actually use WinDBG to attach to a ReactOS instance that's running a virtual machine, just like you would attach to a Windows operating system. And you can use the same WinBag extensions that Microsoft wrote to analyze hangs, deadlocks, and issues happening on a ReactOS machine, just like you would on a Windows machine. In fact, when a ReactOS machine crashes now, and you connect it with WinBag, WinBag will analyze the crash dump and ask you if you want to send it to Microsoft, so they can analyze it. And we always click yes. And I have friends who've actually told me they get these dumps, which look like Windows. They start looking at them, and at some point they go, "What the?" So we like wasting your time. So the way we test ReactOS is two ways. First of all, developer-centric testing. So we write unit tests, functional tests, and we have a whole testing suite that I'm going to talk about. The other kind of testing is we have all these users that are trying it out, running their favorite app, trying their favorite thing, and finding it. Oh, I'm back. Try to run Windows, try to run Mac, try to run Linux. There aren't a lot of operating systems out there. And so if Windows, Mac, and Linux are all accessing hardware in a certain way, a virtual machine developer might think that that is the way that they're supposed to return the output. And if ReactOS does something differently, which is how the Intel CPU is supposed to do it, but a virtual machine ended up depending on how Windows expects it to do it, we might actually find bugs in virtual machines. So we found some of those in QEMU, which is an open source virtual machine project, and we actually have a developer that left ReactOS to work on QEMU, and we found bugs in VirtualBox as well, which is a Oracle virtual machine, and we send them patches as well. So we find bugs in VM products as well. Switching to CMake and Ninja made us one of the biggest projects in the world that uses CMake and Ninja, and we also found some bugs in those, so we sent patches as well. So just because we're taking a lot of projects that were not meant to deal with the size of an OS, And also because we're taking all these open source libraries and compiling them with Visual Studio or running them in a Windows-like environment, we're finding bugs and helpfully submitting patches. So it's been interesting to see the kind of collaboration that we can have. So today, ReactOS has a kernel that's about 80% complete. So kernel-wise, we're actually doing fairly well. The memory manager is the one thing right now that's undergoing a really big rewrite because it was originally based off some Linux concepts and some general computer science concepts, but not around the real things that, the real complications that NT brings to it. Now, the plug-and-play manager is also fairly custom. So the two big things in a kernel that are not really compatible with NT right now are memory management and plug-and-play management. The security subsystem works, but there's a lot of things that are not working right. So up until a few years ago, actually, any kind of access check always said, yeah, you can access that. It wasn't the really big thing we wanted to do. But scheduling, interrupts, process management, device driver support, inter-process communication, all these things are binary compatible with Windows, and they're usually source compatible with Windows. In fact, someone asked me earlier during a training, do you use the same function names? Yes. The same structures? Yes. And so when I'll show you WinBag, WinBag actually is the Windows debugger that relies on certain structures being named in a certain way, fields being in a certain location. And the fact that WinBag is actually fooled into being able to debug ReactOS shows how close we are to that. In terms of other than the kernel, you have all the drivers. And we support a lot of drivers today. And so sound card drivers work fairly well. Network drivers work very well as well. Video card drivers work, but some things we just don't support yet. Like there is no printing support. USB support is iffy. And other things like Wi-Fi support, I think we support one wireless card. So we're supposed to be compatible with drivers, but a lot of drivers use functionality, calls, and behaviors that we simply haven't implemented yet, and so we're working on getting there. Now, the window management is the nasty part. The window management we have is based off Wine, and Wine is based off talking and converting the window manager calls to X calls. So Wine doesn't really do any window management. It relies on the Linux window manager to do everything. So we have to write our own window manager, which is compatible with Wine's window manager, which isn't really Windows's window manager. So we're kind of in a bizarre world where we're trying to make things compatible, but use as much of Wine as possible. So our window management, which is called win32.sys, is fairly different from how Windows implements it internally, which is probably a good thing, because if you've ever done Windows security, if you look at the patches that are coming in every month, there's been about 150 exploitable kernel bugs in the window manager of Windows about every year. So thankfully, those are not our bugs. But a lot of security companies are coming to us and saying, hey, can you hurry up and make it more like Windows? Because then any bugs you have are going to be bugs in Windows too, and those are worth a lot of money. And other than that, in user mode, mostly all our DLLs are from Wine. And Wine has a lot of support. I mean, Wine can run almost 20,000 Windows applications today. And so we should be able to run everything that they run. And if we're not able to do that, that's because we have some bugs, or because the Wine DLLs are expecting to be running on a Linux kernel. And so because Wine runs on top of Linux, sometimes the way they do things, sometimes the way they expect things, is related to how Windows does it. Is related to how Linux does it and not how Windows does it. So whenever that happens, we actually have to fork their code and add differences to make it work on Windows. Just recently, about 2 weeks ago, we were actually able to get the Windows Session Manager, smss.exe, the Windows Subsystem, csrss.exe, the Windows Subsystem Server, csrsrv.exe, ntdll.dll, and kernel32.dll, which are some of the most core Windows binaries out there, copy them on top of a ReactOS installation, reboot, cross our fingers, nothing broke. It still booted, the app still worked, and so we got to a level, and we were really shocked. Like, we took Microsoft's own DLLs, put them on ReactOS, and they didn't freak out. And so we got to thinking, we have all these tests that check kernel32 APIs. And right now we have about 40 failures. If we take the Windows kernel32 and we have 30 failures, that means that 10 of those failures are probably actually bugs in kernel32, But the other 30 failures, they're happening even when running Microsoft's kernel 32. So now we take a test and we run it on Windows and we get 0 failures, which means those 30 failures are not actually caused by bugs in kernel 32, but by something that kernel 32 might be calling. And so we're like, well, this is the greatest way to find where our bugs are. Start taking Windows binaries, drop them in, and see what happens with the regression tests. See, are we doing better or worse? We'll probably be doing better. But if the count of failures doesn't go to 0, that means the bugs are not in that module, but something in that module uses. And so if we find out everything that kernel 32 uses and slowly replace all those things, the failures will go down. And so we actually started fixing a massive amount of bugs in the last 2 weeks by saying, okay, we still have 30 failures. Let's try bringing this in. Oh, 29. So this thing has one bug at least that's causing this thing to fail. And we start debugging it, analyzing it, and we find the bug a lot easier. So we're actually doing a lot of effort right now to try to get Windows binaries, just drop them in and see what happens. And of course, the real cool future would be when you can take ReactOS binaries, drop them in a Windows installation, and it just works. Because those ReactOS binaries will have source code and symbols. And so if your app crashes when you're calling a Windows API, if you're using the ReactOS version of that DLL in Visual Studio, you'll see the C code. And you can actually see, oh, it crashed here because I used the wrong parameter. And there's even a comment that said, use the wrong parameter, instead of having to reverse engineer the Windows DLL. So as I mentioned, Wine can run 20,000 applications. We can run maybe 100. And so anything that Wine runs that we don't must be because we have bugs in the kernel, in our drivers, and in all the DLLs we're not taking from Wine. So our hope is to keep working on this and find these issues. And a lot of times, an off by one bug in the kernel can cause a DLL not to work right, and 1,000 applications that rely on it not to run. And so it's always nice when you fix a tiny little bug and then suddenly Office loads. So once we fix the memory manager, the cache manager, we actually think we're going to get a lot closer to where Wine is. And once we fix the plug-and-play manager, we actually believe that we're going to get almost complete compatibility with the Windows drivers. Because Windows drivers use object management, memory management, and plug-and-play mostly. And we have all of that other stuff. Plug-and-play is the one thing we know isn't really working right. So once we fix it, that should just help out a lot with the drivers. Now, fixing all those things will make our back-end code very compatible. But at the end of the day, the biggest bugs ReactOS has is how things are rendered. And things aren't rendered that nicely because of our window management. We have subtle timing bugs when applications are sending window messages between each others, and we have not so subtle, horrible rendering issues. Someone asked me at Google, can you run Chrome? And I tried it, and it runs, and everything just renders as one pixel. So we have a lot of work in that area. So that being said, you can help. We actually always welcome new developers. We have a whole team, not just of developers, but also web designers, testers. We have artists that actually make the art, the icons. I didn't even talk about all the icons. And the strings. Windows supports hundreds of languages. ReactOS, you can install it in Catalan, in Basque, in Spanish, in French. Not yet in Quebecois, but maybe one day. And we have people who do nothing else but translating ReactOS, not the source code, but the strings in their language. We have people doing PR. We have people that are just enthusiasts. And of course, we have people with money giving us donations. You can always help that way too. And you don't have to be a kernel coder. I mean, I'm a kernel coder. I mostly work on the kernel. But if you are just interested in making an open source version of Photo Viewer or some bizarre Windows app that ships with Windows, so not Calculator because we have that one already, but some like sound recorder. We don't really have a good sound recorder app. We have a sound player, but not sound recorder. You could be the one who wrote the ReactOS sound recorder, as long as it kind of looks like Windows's, because we care about that. Then that's good. You can take a tiny little DLL that Windows ships with that has 3 functions, like compress.dll. And you can try your hand at implementing compress.dll for ReactOS. You can take calc, and maybe calc doesn't do square roots yet. It does, but let's say it doesn't. You can be the one that added the square root function. You might be able to find a tiny bug, a tiny typo in some kernel function. Maybe it has nothing to do with being a kernel developer, but there's an if statement, and instead of having a brace, it has a semicolon, and so the if doesn't really execute, and the semicolon always executes. And you fix that bug, and because of that, Firefox runs better. In fact, you don't even have to be a C Windows developer. You can be a Linux PHP developer, because all our infrastructure runs on Linux, and all our backend stuff runs on PHP. And you can be an artist. All those little icons that Windows has, from the start menu to the little Windows logo to all the other things, we need people to write that. We can't, those things are copyrighted. We can't just copy paste them. You can't reverse engineer an icon. You're copying it at that point. We actually have a fundraising campaign going on for 30,000 euros. Euros because ReactOS has an actual foundation, nonprofit foundation in Germany, and we've actually got 15,000 euros so far. So other than paying infrastructure, this money is not going to pay any of our developers, but instead we have contracts. So there's some things that we simply don't know how to do, don't really feel like doing, and maybe don't have the skills to do, but maybe other people do. And maybe they're lacking the motivation to do these things, but for a little bit of money, maybe they'll do it. So we have a little contract that say, you know, if you do this for us, we'll pay you this much money. Now, if you're working for Google or a large company, these are probably not going to be worth it. These are really meant for students that are trying to get some experience, but they're lazy and they need some cash. Like I think I have one example here. Shell development contract. So if you improve our Shell 32 library, so you can run our, so we actually had this guy that wrote a clone of Explorer, the shell, the start menu, the taskbar, the desktop, and everything. And it worked fine in Windows. He had a 100% Explorer clone. But that's because in Windows you have a library called Shell 32, which gives you most of the shell's functionality. In ReactOS, our Shell 32 is not that good, so his Explorer doesn't really work. So now we have to fix our Shell 32 to run his Explorer. So we're going to pay 600 euros for 100 hours of work, which if you're a 16-year-old in Europe, is not that bad. I think Spain has like 30% unemployment. They can go work on that. So again, you're not going to find thousands of dollars here. We're not like a mega corporation, but you know, some money on the side for your little brother that knows a little bit of coding. Why not? So if you want to reach out, see more about what's going on, talk to us. ReactOS.org is where we have a forum, mostly for users to talk to each other as enthusiasts to kind of try things out. We have an IRC channel on irc.freenode.org where a lot of the open source projects hang out in. There's ReactOS and ReactOS Dev, and pretty much all the developers hang out there at different time zones. A lot of them are in Europe, some are in Asia, etc. And we also have a mailing list, brosdev@reactos.org. So I think this is getting recorded. But so if you don't memorize these things, you're okay. Though you can probably Google for ReactOS. It's not going to be that hard. All these things are on the wiki. I'm alex.ionescu@reactos.org. I'm also here. So if you want to talk to me after, you can ask me questions. And if you're in any way interested, any of these channels are good ways to get in touch. So I actually want to go ahead and demo what this thing looks like. Does it really work, or was it just lying the whole time? So I'm going to use VirtualBox, which is an open, well, it's not really, half of it is open source, but it's basically a VM that lets us run ReactOS. So I'll just run it, a pre-installed version, and then I'm actually going to go through and just show you how the install looks like. So let me make it full screen. So this is the boot resolution is kind of weird. Boot manager. So if you've ever used the old NT loader, that's what you get in XP if you press F8 at boot up time. So I'm going to tell it to boot ReactOS. And I need to fix it. I won't make it full screen because otherwise you won't see the whole thing. Let's see. Oops. All right, let's try that again. So let's just do another reboot just so you can see how fast it boots because it's really impressive. All right. So this is because I've got my boot CD. I don't want to boot from the CD. And And that's it. It actually played a boot up song too, which if I plugged in this thing and you'd hear it. So here's your Windows Phone. The lag is because if this is like streamed on Google Hangout and streamed back here and streamed to like Mountain View or something. So it's not actually, the mouse is not actually looking at that, trust me. Start menu, programs, explore, games. What's the one thing everyone likes to do? Solitaire, Minesweeper, yep. So for the company out there that's paying Windows licenses so their devs can just play Minesweeper, we have Minesweeper. We don't have hearts though. So if anyone wants to write hearts, that would be great. We have Solitaire, we have Spider Solitaire, we have a command prompt. So let's actually try to go online. So one thing we do have that Windows is not, and we try to stay away from those things. We don't want to we don't want to do things that Windows doesn't have built in. But because we are aware that there's a lot of things we don't ship with, like we don't have IE, and we probably never will have IE, we do have an applications manager, which is similar to an app store, basically. And I can go on Internet and Network and download BitTorrent, of course. We fully support BitTorrent, IRC, or Firefox. But I think this is the Visual Studio build, so I think as soon as I click, it's going to freeze. Oh, no, okay. Firefox 23, install. And this is actually going on Mozilla.org and downloading the Firefox installer, which hopefully will. This is usually a lot faster, but you're probably all on Wi-Fi now. All right, so we'll let that run in the background. Actually, let me get an older version so I don't make you wait forever. Firefox 2. There we go. Is that one smaller? Still big. Let's try IRC. There, that's better. And this is 100% MIRC from MIRC.com. It's not customized. It's not a special build for ReactOS. It's the actual MIRC installer. Almost done. Let's hope it works. Otherwise, you're going to see a ReactOS blue screen of death. It works just like a Windows progress bar. And let's see if we have the setup. Yep. There it is. Next. I agree. Sure. Next. 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 And super fast. And let's launch it. Looks good. And I could go and connect to an IRC server now. So this is a bona fide Windows app running on ReactOS. And this is actually now that works fairly well. I mean, I can't actually see that there's I don't see any visible rendering issues or anything like that. So that's when things go really well. When things don't go well, then you just get a blue screen of death, or things get rendered all over the place, or things just look really, really, really bad. Sound works as well. So we have let's see, accessories, nope. Multimedia player, and I can go play the logon WAV file. Where's some? There we go. There we go. So everything else is now ReactOS. You want to see assistant properties. So one of the things we try to do is have a very similar experience to how a Windows machine would work. Because a lot of companies, one of the reasons they don't want to use Linux, or they're afraid to move to something else, is if something goes wrong, they have to have someone trained that knows how to fix it on Linux. But when you have a device manager that looks just like on Windows, when your properties looks just like on Windows, and you know that on Windows you can right-click and disable the device to get rid of it, you can do that in ReactOS as well. So we really try to make sure that the interface and everything else works and looks like it should on Windows. Let me show you how you can debug this thing. So I'll actually turn off for a second and launch WinBag, the Windows debugger. Tell it to connect over a named pipe, start ReactOS in debug mode. And I'm going to scroll up because this is quite funny. This is WinBag thinking that it just connected to Windows Server 2003 and that it can't find the symbol files on the Microsoft server. So this is just basically debug output from ReactOS, and I'm going to give it the right symbol path to where I've actually got the symbols built. And now it took the symbols, and if you've ever used WinBag, for those of you that took the training, for example, at Google, bang process 00 is how it's going to give me all the running processes by going into some very deep kernel-specific structures that only the Windows kernel has. And it just gave me all the processes like it would on a real Windows machine. I can do bang process 01 and see all the information about all the processes. I can see the current stack and the actual C files that correspond to these functions, which is as close as you're ever going to get to NT kernel code without working for Microsoft. And I can step, if I had the sources checked out, I could actually step through kernel code with the source debugger, put a breakpoint, see variables. I can still do it in assembly, but I don't have the source file, the sources checked out on this thing yet. So I can press go and go back. So honestly, really surprised that a super internal Microsoft debugging tool can be fooled into working on something that's not really Windows. So last thing to show you is how does this thing install? Because we wanted to make sure even the installer looks like Windows, Windows XP. So if you've never installed Windows XP, probably don't remember this, but this is how it used to look like. Yeah, that's right. Yep. And the only difference from XP is that this is how fast this thing installs. Yeah, there we go. Bam. Thank you. And what happens when you reboot Windows after going through tech setup? You get the whole second stage setup where all your devices are installed. So now if I boot it up, it's going to boot up and register all the COM components, asking for my username, my password. It's not going to ask you for your license key. Name. There we go. Next, next, next. It actually asks if you want to install Mozilla right now, so you can actually have a browser. I'll say no. And now the second time I reboot, I'm going to get the desktop and back to where we started. So it's actually surprising that, I mean, honestly, this is probably 10% of what everything Windows has. That's why it builds so fast, links so fast, boots up so fast. But it can still run MIRC without a single problem. That tells you how much bloat there is in Windows. If all you want to do is run BitTorrent, IRC, and use a web browser, you don't need all that. So this is what happens to our beautiful add device wizard when you compile it with Visual Studio. With GCC, it looks perfect. Like you'd have actual text here. So something is different. We have a bug that's not exposed in GCC that is exposed in Visual Studio. And that's like really kind of awesome stuff you find out when you use multiple compilers. So I could demo this all day, but you probably have better things to do. So I'll open it up to questions. And I can pass this around, I guess, or you can yell really, really loudly, or you'll pass it on. There we go.
All right, questions?
Hi there. When you actually started your presentation, you actually stated there was a lot of legacy code in Windows. And I guess the best example I can think of right now is DirectShow, which is being throttled around and being like it's deprecated to Windows Vista, but it's still there in Windows 8. What is your best example on while you were working on ReactOS of, oh God, that's still there?
Does this work somewhat? Okay. So back in 1991, IBM was working on something they call ABIOS, Advanced BIOS, which is a 32-bit BIOS. And Windows had a partnership with IBM, and they went ahead to implement support in the kernel for ABIOS. That never shipped. But we actually implemented it because we didn't know that if this mattered or not. So we did all the work to implement it. And then somewhere around 2 years ago, someone from Google Mountain View found a horrible exploitable bug in the kernel by leveraging that code path that no one had used in 12 years. And that's when, oh God, we actually implemented that and got rid of it. So I think that's one example. You find another favorite of mine is the 386 had a bug in it that you could work around it. So most OSs would detect what kind of 386 processor you have and then work around the bug if needed. Windows had that code too. Now around Windows 2000, they stopped supporting 386, and around Windows XP, they dropped everything but the Pentium. But Windows 8 today still detects if you have that bug on a 386, fixes the bug, and then about 15 microseconds later, crashes because you're running on a 386. So, good question. Yep.
Okay, so first of all, since you're using Wine, does that mean that to a certain extent Steam can start running and then crash?
I've not tried. You should try that.
The follow-up question would...
I know that some 3D games actually work fairly well, like Unreal Tournament 2003 works, so maybe Steam works too.
Okay, so the follow-up question would have been, will it run Crysis?
Not Crysis, no. But SimCity 2000, yes. In fact, if you go to reactors.org/screenshots, there's actually some screenshots, and I'll put them up while I answer the next question, I guess.
Next question.
Over here.
Thank you. Any other product that work on ReactOS, like Photoshop?
Photoshop, that's a good question. I know that GIMP works.
Okay.
I'm pretty sure older versions of Photoshop work. I mean, so one thing we have on one of our websites is the app database. So we're migrating our website, but on the old website we had a AppCompat database, and you're asking about Photoshop.
Any other product is gonna be fine.
Yeah, I mean, there's a lot of projects I can think about that work.
And any plan for running ReactOS on quantum computers?
When you buy me a quantum computer to try on, I will let you know.
Well, I actually build a mini quantum computer at home, and I run Gecko Firefox browser. That's only Gecko and nothing else on the quantum computer. So
You should download a source code and try to build it. And we actually have an ARM port, for example, that some people are trying to get working on Raspberry Pi. So try it out. Any other questions in the back?
So you talked about how you have a lot of like different ways of testing things which you normally probably couldn't do in a regular OS, things like, dropping in a DLL from Windows. Do you automate any of that, or is that all like using something like Delta debugging or something, or is it all manual?
Specifically, everything is automated normally, except the dropping the DLL. So the dropping the DLL is something we literally just discovered 2 weeks ago that, wow, this works. So we're doing it manually, but we're actually in the process of setting up a build server that that basically has alongside of it all the Windows DLLs, and we can tell it through someone's building a web interface. So we can say, I want this DLL, and then it'll install ReactOS, copy the DLL, and then run the test. So we're working on automating it because we think it's a really, really great thing. Something I didn't show in the demo, by the way, is we actually support XP themes. So if you take your luna.ms styles or any custom XP theme, you can theme ReactOS. The same DLL, the theming DLL actually works.
Yeah, I have a question. How long does it take for someone to get himself or herself used to all the standards and the parameters, the structure of the OS that you have there? Because I assume there are some documentations that people can use.
Yeah, so if you're not familiar with Windows at all, it's probably going to be a little bit longer. But if you are familiar with Windows, you're going to see like a ReactOS /DLL and then / all the DLLs, and you can click, oh, kernel 32, and here's all the files, or ReactOS /kernel. And then if you know a little bit about what's in the kernel, you'll be able to see that. So, if all you're trying to do is work on an app, there's like /applications. So the stuff is really well ordered. Now, in terms of actually checking out your first build, building it, we have a wiki page that pretty much tells you from A to Z how to build, how to check out, how to build, how to test, how to do all that. And people are really friendly. Like, these folks really want to help out, and you can come on IRC, send a mailing list. So honestly, if you've done some Windows development, even if it's just been like a Visual Basic app, probably a week or two, and you can probably start contributing actual code. And at the beginning, your patches will be as patches on Jira on the bug tracker, and then we'll review them for you, put them in code review, tell you what you did wrong, how you can do better, check them in, and then after you submit a few patches and you're comfortable and we're comfortable, then you'll get a developer account and you can start checking in code like everyone else. I've got MSN Messenger screenshots here, so no one really uses that anymore, but it still works. The .NET DLL from Wine actually works, so anything that uses Passport should work out of the box as well. Other questions? Yep.
So I was trying to think of the most awful part of Windows that I could think of, and I guess I came up with DCOM. So I'm wondering how fully you've implemented DCOM.
I'll answer that. The most important game in the world works on ReactOS. So DCOM is all from Wine. So as good as Wine implements DCOM, ReactOS implements DCOM, except DCOM uses name pipes, and name pipes is our implementation, and we actually just rewrote name pipes because of some bugs. So DCOM uses RPC, which is name pipes. So it should work as good as Wine's DCOM works. And since Wine runs Office, which is heavily DCOM focused, I think fairly well. Here? Oh,
I got one
yep.
just before. I was wondering if you knew at the time of PC Linux OS, which was doing a similar thing to ReactOS, and if you know about the differences in between them. They were, if I remember well, they were using Direct3D libraries fairly early.
I know some projects that would take Linux and run like Windows libraries natively on that. So a little bit more than Wine is doing, but not still ReactOS. So I don't know about all of them specifically. I don't think I've heard about this one. But yep.
Else, do you have any connection with like portable apps? Like, is there a way that you can do the things that portable apps are using, which you have those libraries?
Yeah, some people asked us about that, and I know that if you take certain portable apps and you can just run them on ReactOS as well. Some people are trying to basically trying to make portable ReactOS, where you take a Linux install and you have a VM with ReactOS with a portable app, and you just drag and drop, and now this Windows app works, which is almost pretty much what game developers are doing with Mac versions. It's a portable app version of Wine. So we're looking at some of that as well, but we're not quite there yet. Yep. Exactly. Diablo 2 also works in ReactOS. Yep.
Hello, my name is Olaf. I'm wondering if it's self-hosting. So do you run Visual
You
Studio?
cannot run Visual Studio in ReactOS yet. Probably when we do that, we'll be done, because that thing is probably one of the most massive, complex pieces of Windows code ever. But GCC does run, so you can actually build, you can run CMake and Ninja and GCC, and you can build ReactOS in ReactOS if the memory manager works out and if the file manager is happy. So if you have a really good disk and you give it a lot of RAM, it should work out. It's not something I'd recommend yet, but it works.
Yeah, another thing, related to that, because I mean, not needing Windows to build something would be great. How about something like testing websites and stuff like that? I mean, have a lot of people tried to do that, or?
Well, I mean, in terms of websites, we use either Gecko or Firefox or Opera. Chrome doesn't run yet, so.
Internet Explorer.
Yeah, Internet Explorer is so deeply tied to Windows that it'll never work on ReactOS probably, and we don't want to reimplement. We don't want to reimplement a browser when there's already really good browsers out there. So what we actually have is we have Gecko that we load in an IE compatible frame. So the IE COM object, we render that through Gecko, which is what IE does. But in terms of website testing, I'm not sure it's going to help much because you're going to see the same stuff Opera sees on any other OS, plus all the rendering bugs ReactOS has. So unless you really want to fix your website to render correctly on ReactOS, thank you, probably not worth it.
Okay, we'll take 2 questions.
What kind of language used to automate out test cases?
Most of ReactOS is written in C. I actually had a little chart here to show you. So this is like our line of code progression. So most of it is C. Sorry, this is not code metrics. We have a little bit of C++, and most of the web stuff is in PHP, JavaScript, and so on and so forth. So we follow the same language that Windows wrote, which is mostly 99% C. A lot of stuff in user mode is C++ though.
So for the test platform is open for public or just
the test platform uses. Oops, this is not what I wanted to show. I just realized. The test platform is a lot like Testman is all PHP. AutoHotkey is an open source tool that someone else wrote. What we really customize is sysreg and sysreg2, and those are in public. So if you go to SVN, ReactOS/tools/regression, you'll see all the tools you use. So the whole website is in a Git repo. All the tools we built are in a repo as well. So not just the OS is open source, but everything we've built to support the OS is also open source. So yes, you can use our testing platform on something else you might be working on if you want to.
So everybody can build up their own test platform,
Yep.
right?
Yep.
Okay, thanks.
Sure. And I'll hang out. So for those of you who are not asking questions, you can ask me later, after this is done, no problem.
All right, so you said that the project aims for compatibility with Windows XP, but what if, for example, in Windows 7, there's some function that's been added to user 32 or something like that? Will you also implement that function, or will you just refrain from doing it because Windows XP didn't have it?
So yeah, support for Windows 7 and other functions has kind of really been on top of our head. The reason my first answer like 2 years ago would have been no, we would stick to XP. But what's happening is that we are starting to see some applications that have dependencies, right? And the reason I said no XP only is because if you're chasing a moving target, it's very hard to know, is my bug because I have implemented part, there's actually there's a bug in an XP DLL that if you fix the bug, obviously the kernel won't work. There's a bug in the kernel, and if you fix it, then a DLL won't work. But if you reverse engineer the Windows 7 DLL, the bug is no longer in that DLL because they also fixed it in the kernel. So I had someone argue with me saying, no, you should get rid of this bug in this DLL because look, Windows doesn't have it. I'm like, no, you're looking at a Windows 7 DLL, the 2003 DLL fixed it. And then he's asking, well, how come the bug is not there? Because they also fixed it on the other side. So my worry was, if we're doing half and half, maybe the Windows 7 function works that way because this other Windows 7 DLL works this way and the Windows 7 kernel does it this way. So it's very hard to claim that I'm compatible if you're mixing and matching. Now that being said, we have done exceptions. There's a Windows 7 function in user 32 whose sole job it is to calculate the metrics of a rectangle. Well, that doesn't need anything else than math, and we can implement that. So stuff like that, we've erred on the side. But the annoying thing about that is sometimes if you export or implement or claim to have a Windows 7 function, some apps will see that you're exporting it and will use that to say, oh, you must be Windows 7. I'm going to do all these other things too. So we're actually trying to build a system where you can, at install time, say, do you want to have XP behavior or do you want to have some of the Windows 7 functions? And your mileage may vary. So we're kind of starting to be on the fence about that for some user mode stuff. In the kernel, though, we're going to stick to 2003. Once we're fairly sure it's working, probably actually go to 7 or 8.1. So that's the long answer. So thanks a lot. We also have a coverity scan. Thank you.
Thank you, Alex. This is very, very interesting talk and amazing project.
Thank you. So
the next step you need to do is to get Chrome to work.
Yes. And then Coverity, here's 4,000 bugs that Coverity found. You can get started on them right now. Thank you.
Thank you, and thank you everybody for coming.